Hey everybody, Lars here. Tonight, really quick, I want to do the second part of the Unit 4 review, the part on recursion. And recursion is something in computer science that often throws people for a loop, but it doesn't have to. And we're going to go through a couple of really simple examples. And then I set up a situation where we're going to look at that piece of code in your slides where we do multiplication recursively, and we're going to trace through that. And I'm going to show you exactly what's going on, and hopefully that's going to make things a little bit more understandable. Real quick, I queued some stuff up. Can't hurt to go check out Recursion and Wikipedia, and it basically talks about it. Process of repeating things in a self-similar way. You'll see in the computer science section, you'll see why we use recursion and some different things about recursion. So it can't help to check that out. Recursion is also alluded to in a lot of Escher's art, and often you'll see like people do different funny things like this. I mean, if you think about a mirror that goes all the way down, that's recursive. And things along those lines. Also, Russian dolls are often consulted and stuff like that. But in a computer science context, and here I think let me make sure. Yes, I set up a test area so that we could quick code something up. At its heart, recursion is usually shown in computer science with a function that refers to itself. So it is self-referential. And we'll see that because of the behavior of functions, if we can find a problem where you can remove one small thing and then do that same problem with the smaller subset and go all the way down the line with that, those are the kind of problems that we want to attack with recursion. I'm just going to real simply, let's say you wanted to find the sum of all the numbers to a certain point. So if n is 5, we want to add up all the numbers and get 15. So let's say I could do that. I'm going to do it rather quickly so we can get rolling here. I call it my sum, and the first thing I'm going to say is if n equals 1, just return it. And you'll see why in a second. Just return n. Then if it's not, return n plus my sum, and then you give it the smaller list or the smaller number in this point. Okay, now I'm going to show you how that works. I'll say a equals my sum of 5 and then print a. Yes, I'm going to start doing everything in one line so you can start seeing that. I'm still doing things in the we're in learning mode way, so I set variables then print variables, but we can just print that in the, stick the function call right in the print statement and do the same thing. So let's see what I get. Hey, it worked on the first shot. Alert the media. So I get a 15. So what was really happening here? What I did was I called my sum with a 5, and I came up here with a 5. Is it equal to 1? No. So I go to the else. Return 5 plus, and then call the function again with 4. You see? So then when you call it again, you'll just run another copy of the function. Oftentimes with recursion, people run into trouble because when they see how a function works, they have this picture in their head. And they'll say, okay, I go here, then I go here, then I go here, then I go here. And then when they see something referred to itself again and have to go up and use it again, well, they forget about the layer beforehand. Now, hopefully I got a solution for that, and we're going to see that in a couple of minutes. But basically what you do is you say my sum of 4, you run through with 4. So that version of the function is going to return 4 plus my sum of 3. And you go all the way down the line until you get to 1. And when you get to 1, you don't call yourself. So you end the self-referencing and you just return the 1. So what do you return the 1 to? The call beforehand, which will then add it to 2 and return. Now what will that go to? The call beforehand, which will add that to 3 and return 4, 5 until you have 15. Okay? Classically, in computer science, what we usually do is we do Fibonacci numbers or factorial. Actually, by the look of that, factorial can happen really fast here. Hold on. Factorial. Call me crazy. I think this is factorial now. Let me do this. And factorial 5. What is factorial 5? Is that 120? Yep. So as you can see, that we easily just took that little sum and did a factorial with it. Same concept. 5. Is it 1? No. So hold back the 5 and then give it my fact of 4. My fact of 4. Hold back the 4 and give it my fact of 3. So you're calling this function 5 different times. Okay? So then when you're done and it's equal to 1, then you come back up the stack, we call it. And every time you return, you're going to multiply by the number before it. So you multiply by 2, then by 3, then by 4, then by 5. And then you get to the last call, which returns 120. Because that's the answer, and that's what we get right there. Okay? Remember, and I said it 2 days ago when I did the other one, this is YouTube. You can stop it. You can look at it. You can see what's going on. I want to do this just to reiterate what we just talked about because I like to trace through. Is this multi? Yes. As an example, I showed you factorial, I think, in the slides, and then I want to say, you know what? I want to show you something that you're familiar with and that you're used to using, and that would be multiplication. So I created this little function. And it works. Where all you do is, if you want to multiply two numbers together, you send the function those two numbers. Yes, of course, something was going to go wrong. 9 o'clock, I got alerts on my Google Calendar. I do turn off my email, so that doesn't give me alerts, but apparently I didn't get everything. So I go 3, 3. My mult, 3, 3, is times 0. No, it's 3. So what do? I come down here. I return the number, which is 3, plus, and then I call the function again, only this time I call it with 3 and 2. And then I go back to the top and back to the top. But I think I have a better way to trace through this program for us. At least we will see if I'm correct. Okay, do I have this on pencil? I think I do. All right, the first time you call the function, right here, you have number 3 times 3. Is times equal to 1? No, it's not. It's equal to 3. So return num, which in our case is 3, and then call my mult with num, 3, and times minus 1, which in this instance is 2. And where does that happen? Right here. Okay? So I have my num is being called. It's 3. My times is 2. Is times equal to 1? No, it's not. So return num. What's num? 3. And then call my mult with num, which is 3. And times minus 1. Now times is 2 in this pass, so this time it's going to be 1. So where is this call? Right here. Now this is the better way to think about recursion because you're not dealing in the same function. You're dealing with a copy of it. I mean, that's the way the compilers work, and that's the way that the computer programming works. You're dealing with a copy of it. You're grabbing another copy of it from memory and going and using that. So it's not like your workspace is the same thing and you have to get all, convoluted. You're getting another copy of it. So this time, at the very end, I'm calling it with 3, and times is 1. If times equals 1, check. This time it does. Bingo. So I return num. So what do I return? I return 3. So up here where I called it, this entire thing returns a 3. Okay? So now I'm ready to go back up to the call before. Return num plus 3. What is that? 6. So what gets returned to the function up here? A 6. So now, and this was the original call, I return 3 plus 6, or 9. And that's the answer. So basically what we're doing with recursion is we're taking advantage of the way functions work. We're taking a big list, grabbing a part of it. As you can see, I grabbed the num here, I grabbed the num here, and then sending it to the same function with a smaller list. I reduce my 3 to 2. I reduce my 2 to 1. Here I have my 1, and I go back up the list. Okay? Got it. Looks confusing now. I hope it wasn't as confusing when it was explained. So, and that gives you 9. And 9 is the answer to that particular problem. Now, if you could probably imagine if I did 3 times 84, things could get a little complicated as far as tracing it, but it's the same concept, and it works the same way. Okay, so that's factorial. I figured I'd trace multiplication and not factorial. And that's multiplication. Now, you're probably asking yourself, okay, so far we've seen examples like factorial and summing up a list and multiplication. Why would we bother doing this? Why would we, what is it, a contest to see how, convoluted and crazy we can solve problems? Some would say yes, but recursion is important to learn because later, and you'll see some of this in Unit 6, we're going to get to data structures that really lend themselves to having recursion used on them. One of them is called a binary tree, and when you see a binary tree, you're going to see a binary tree is made up of smaller binary trees. So when we do recursive functions on binary trees, searching through them, adding nodes to them, boom, 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 recursive functions are going to be very elegant, short ways for us to do this. It also comes into play in drawing. When you draw recursive things, I don't know, Mandelbrot in some cases, and Sierpinski's triangle, you'll see, I think that's actually mentioned in the recursion page on Wikipedia. So you'll see all that later. Right now, again, I say it all the time, I'm a broken record. I just want you to be exposed to these things. I want you to know the basic ideas and see them in use in a simple context so you can say, I know what recursion is. It's a function that's self-referential, and it works by making all of those function calls, and as they come back up the stack, they perform their operations one after one until you get to the original call, and then you have your answer. Okay? So that's it. That's recursion. I'm not going to say this was short because I always say this was probably short, and it turns out it wasn't, but we'll see what we get. That's recursion. That's all done. Not going to clobber you with announcements tonight either. Really quick, I'm sending back Unit 3 grades tonight. For the most part, everybody did a really good job. I'm really happy because, as I've said in the past, Unit 3 was the next level thing. It was a bunch of complicated things that you had to all get working together, and for the most part, everybody did. Now, if you didn't get your grade back, give me a day because I'm about halfway through. I hope to do more later on tonight. I'm a little bit under the weather, so I don't know if I'm going to end up conking out on the couch as I watch the second half of the Panthers and the Colts. But I'm also in mourning. As we all know, the Mets got bounced. And they got bounced in a terrible fashion. Our pitcher, Matt Harvey, did really, really well for 8 innings. And then he came out in the beginning of the 9th, walked a guy, gave up a double, and then he finally got replaced, and the game was tied. And then it went into extra innings, and Kansas City ended up winning an extra inning, so the World Series is over. At the end of the day, I think it was a case of Kansas City being better than the Mets. But we were hoping to whistle past the graveyard and get lucky, and we had some outstanding pitching that really pitched well in the playoffs, and I was hoping that maybe that would get us by, but it turns out it's not the case. But it's going to be a great year next year. Most of the guys are coming back, and as usual, if you're a Mets fan, always a bridesmaid. All right, so I'm going to have a lot of free time now, that's for sure. That's one good thing that comes about when the Mets get knocked out. So that's a good thing. All right, so this is the recursion video. Let's see. I think we're pretty much there when it comes to all of the resources and the things you need for Unit 4. So chug along. You've got your slides. You've got your 2 review videos. You now have the assignments, so you can think about what you have to accomplish as you look at the slides and the videos and you read Zell Chapter 13. So you should be in pretty good shape. I'm going to set myself to creating Unit 5, and Unit 5 is going to be interesting. It's going to be object-oriented programming. So there's going to be some next-level stuff there. All right? All right, you be good, and I am getting out of here. Have a good night.